Welcome back to TED Talks. We were dealing with biology, and so far we have reached this level. We are looking at monosaccharides. And a class of them for this session according to the number of carbon atoms present. That's what we are going to center on in this session. Classification of monosaccharides according to the number of carbon atoms present. In the general formula, Cn H2n ON. Let's start by one. If n, the smallest n we can have, can be 3. So n is 3. If n is equal to 3, then what will be the molecular formula? The molecular formula is going to become C3H6O3. These are collectively, whichever sugar takes up that molecular formula, are collectively called trioses. Tri coming from 3. So we have two types of trioses per now. We have glyceraldehyde. Glyceraldehyde obeys this, but it is an aldose. It has an aldehyde group, so it looks like this. An aldehyde group, the alpha carbon at least is bonded to. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3. So this is an aldehyde, an aldose, a triose with 3 carbon atoms, and that's how they are bonded. We are looking for the reducing properties. We remember from chemistry point of view that an aldo group is a reducing agent because itself gets oxidized to a carboxylic acid. That is one example. The other example is dihydroxy acetone. Dihydroxy acetone, it is a ketose. It is a ketose sugar with 3 carbon atoms. It is a triose, so it takes up such a shape. 3 carbon atoms, and that is the alpha carbon. Since this is surrounded by 2 carbon atoms, we can now able say it is a ketose. So this is OH, that is OH, that is H, 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 H. So this one is an aldose. So collectively, these are obeying the same molecular formula, but have different arrangements of atoms. So we can even find it in category number 2, according to arrangement of atoms in the sugar. So the difference is here just. Carbon atom number 1, 2, carbon atom number 3. This is carbon atom number 1, carbon atom number 2, carbon atom number 3. So look at where the double bond of oxygen to carbon is located. So that is one category of, according to the number, that is 1. 2, if carbon atoms are, if N is equal to 4, if N is equal to 4, our molecular formula would be Cn, which is now becoming C4H8O4. These would be collectively called tetroses. Tetra meaning 4. They are not very common tetroses, but they do exist. There are some that do exist, like xylose does exist. A sugar which has 4 carbon atoms. Then number 3, if N is equal to 5, if N is equal to 5, it would mean the molecular formula would become C5H10O5. So obeying this, examples are many. Take an example here. The first one is ribose. The ribose sugar found in ribonucleic acids and deoxyribose. How do these differ? How does deoxyribose differ from ribose sugar? They are isomers, they almost share the same molecular formula, but deoxyribose is a little bit an exception. Ribose sugar takes up a cyclic format with such a structure. So these are 5 carbon atoms. Can put 1 oxygen here, 1 oxygen here. Those are 1, 2, 3, 4, 5. Then another one here, 6. Then hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, counting 9. It's 1, 2, 3, 4. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Supposed to have, okay, 10. Because we are obeying this formula. So this is carbon atom number 1, carbon atom number 2, number 3, number 4, number 5. So this is ribose. Deoxyribose will take up such a structure still. It is a furanose structure, 5-sided structure. 5-sided structure, and it will have oxygen there. We lack oxygen there. So it will have that is 1, 2, 3, 4, 5, 6, 7. This is oxygen here. 7. There is oxygen here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the hydrogens are 10, but oxygen atoms, look at them. 1, 2, 3, 4, 5. So deoxyribose is not an isomer of ribose, although they are all pentose sugar. So it is C5H10O4. 1, 2, 3, 4, 5. And to eliminate some. 1, 2, 3, 4. This was it. 1, 2, 3, 4, 5, 6. So this one is supposed to lack oxygen here. So I remain. Even this should lack oxygen there. But look at the difference on carbon atom number 2 between deoxyribose and ribose. Carbon atom number 2 is carrying oxygen in ribose. Carbon atom number 2 is not attached to any oxygen. That's where the name even comes from. Deoxyribose. D meaning removed oxygen. So oxygen is removed from carbon atom number 2. And because of that, these two have different chemical properties and physical properties altogether. Ribose is very useful in formation of RNA. Deoxyribose is very useful in formation of DNA, as we shall discuss these chemicals of life in our subsequent sessions, DNA and RNA. We are still for number of carbon atoms to number 3. If N is equal to 6, if N is equal to 6, number 4, N equaling to number 6, meaning the molecular formula is going to be C6H12O6, giving us a lot of examples: glucose, which we shall understand, fructose, which we shall understand, and galactose. So in our subsequent sessions, we are going into now another basis of categorizing monosaccharides according to arrangement of atoms. So that will be in our next sessions.